So our learning target today is I can identify and solve proportions or proportionate situations using tables only. So we're going to use a table to answer each of the questions. So we're going to go through this process and see what we know about proportional relationships. It's the idea of cross products sometimes. Last year as a 7th grader, we always took things in cross product form because everything we did last year in 7th grade was proportionate. We made sure of that when we gave you the information. What's going to be different in 8th grade is we're going to give you scenarios sometimes where it's not proportionate, you can't take cross products. So if you have baseballs and we have dollars, you have 2 baseballs is $5. How much was 7 baseballs cost? So here's our scenario. Now in 7th grade, you'd be able to take cross products and solve. But in 8th grade, we have to ask us always this question of 0, 0. Asking, is it proportionate? If it's proportionate, it goes through 0, 0. Is it true that if I buy 0 baseballs, I will need $0? Is that true? 0 baseballs, $0. Yeah, that's true. Every time we can say that that's true, that that's a yes, then we can take cross products. So if we are able to say, yes, it's proportionate, then we can take cross products and multiply, divide. So as I start to solve, we would go ahead and say, grab the variable x, multiply across, gives us 2x. Multiply across the other side is 35. Hand method kicks in, divide by 2, copy paste, we get x equals $17.50. So we would say that if we had 7 baseballs, we have $17.50 for 7 baseballs. So our unknown value here is 7 baseballs, $17.50 for the unknown. We are only able to take cross products because it's proportionate. Going back to what we just discussed, you have to ask the question every time, does it go through 0, 0? If it does, then we can say that it's proportionate. Yes, we can take cross products. That's box number 1. We were able to go back to 7th grade cross products because of the proportional relationships. In box number 2, a 6th grade class needs 5 leaves each day to feed its 2 caterpillars. How many leaves would it need each day to fill 12 caterpillars? In 7th grade, what we would do is we would underline the number and we would circle the label. So we have 5 leaves, 2 caterpillars. How many leaves would they need for 12 caterpillars? So we have leaves and we have caterpillars. Leaves and caterpillars. So we have 5 leaves for 2 caterpillars. How many leaves do we need for 12 caterpillars? That's the setup. The question though really is it proportionate? If it's proportionate, we can take cross products and go back to 7th grade math. 0, 0 is the question. Does this go through 0, 0? Is it true that if I have 0 caterpillars, I need 0 leaves? Well, yeah, if I don't have any caterpillars, I don't need any leaves. So if that's the case, if it goes through 0, 0, then we can take cross products. So we have our unknown value here. We're going to multiply across. So we get 2 times x equals 60. Hand method kicks in, divide by 2, copy, paste, and we get x equals 30. So we would have 30 leaves. So we would need 30 leaves for the 12 caterpillars. 30 leaves, 12 caterpillars. Again, going back to 7th grade math, it's a proportional relationship. Okay, so now, those are the first 2 examples of setting up proportional relationships. Both of them allow us to go to cross products back to 7th grade math. I'm actually going to have you skip number 3. I'm not really a super big fan of that question, so we're going to skip number 3. You don't have to do number 3 at all. Going to number 4. Number 4. I'm on page 14, number 4. Let's take a look at this problem. Nathan and Kensley run at the same speed around the track. Nathan was running lap 3 when Kensley was running lap 7. What lap will Kensley be on when Nathan is running lap 9? So we have Nathan running lap 3, Kensley's running lap 7. So we have Nathan and Kensley are the 2 runners. When Nathan's running lap 3, Kensley's running lap 7. That's what those two red highlighted items are saying, or underlined, I should say. Red underlined items are saying. What lap will Kensley be on when Nathan is running lap 9? So when Nathan is running lap 9, so we're going to put a 9 under Nathan, what lap will Kensley be on? Our question then is it 0, 0? Is it true when Nathan is at lap 0, Kensley's at lap 0. So we have to ask this question. If it is a yes, if it's proportionate, then we can take cross products and solve. If it is a no, then we're going to have to work through that. So the unknown value is where is Kensley when Nathan is in lap 9. If we go back, it says that Nathan and Kensley are running at the same speed around a track. Same speed around the track, which means did they start at the same place? What about the start? Did they both start together at lap 0 for Nathan, lap 0 for Kensley? Sorry. Is that true? Well, it can't be true. If we take a picture of what's going on here, if this is where Nathan is at, if they're running at the same speed, and Kensley's at lap 7 and Nathan's at lap 3, they're running at the same speed. They could never have started at the same spot. So here's our first experience in 8th grade where it's not proportionate. We did not experience this last year in 7th grade. Now it says no calculator, so we're going to be doing our work without a calculator here. So we're going to say, well, what's true? Well, it's not 0, 0. They didn't start in the same place because they're running at the same speed. So not 0, 0. And when that happens, you have to add or subtract in the table. When we did proportional relationships, we were multiplying and dividing. So over here, these problems here, cross products is when you multiply or divide. This problem here is not proportionate, so we add or subtract. So what we do know is that Kensley is always 4 laps ahead of Nathan. Always 4 laps ahead. So if Nathan's on lap 9, Kensley's on lap 13. So our answer should be lap 13. So when Nathan is on lap 9, Kensley's on lap 13. Done. So the answer is when Nathan is on lap 9, Kensley's on lap 13. She's 4 laps ahead. It is not cross products because they did not start in the same place of 0, 0. Okay, number 5. Jesse swims 4 laps across the pool in the same time that Kelvin swims 3 laps. So we have Jesse and we have Kelvin. Jesse swims 4 laps in the same time that Kelvin swims 3 laps. Sounds to me like Jesse is a faster swimmer. They are not swimming at the same speed this time. As I start to read then, they begin swimming at the same time. Ooh, important information. They begin swimming at the same time. How far has Kelvin swam when Jesse completes lap 13? So Jesse's completing lap 13. What's going on with Kelvin? The question is, does it go through 0, 0? Well, do they start in the same place? Is it true that when Jesse's at lap 0, Kelvin is also at lap 0? So it says that they start at the same time. So here's the graphs. One of them swimming faster. They start here. We have Jesse is doing 4 laps in the time that Kelvin swims 3. So Jesse's swimming faster, so Jesse has a steeper slope. The unknown is still here. But what we see in this particular problem is that they do start at the same spot. When Jesse's at lap 0, so is Kelvin. They're starting together. It's just Jesse's a faster swimmer. When we do have a yes to this situation, we can take cross products. So we're going to multiply here. We have 4 times x. And if you need your calculator, go ahead and pick it up. You might end up needing it on this problem. Actually, go ahead and pick it up. Give you time to get that calculator, or pause the video and then go grab it. We have 13 times 3 is 39. Hand method kicks in. We divide by 4, copy, paste, and we get x equals 9.75. So the lap, that would have been hard to do in our heads. So when Jesse's on lap 13, Kelvin is on lap 9.75. So you can see that Jesse is always ahead of Kelvin because Jesse's just a faster swimmer, but they did start at the same time, so it's a cross products question. All right, guys, 2 left for today. Dough-Man instant pancake mix requires 3 cups of water for every 4 cups mix. 3 cups water for 4 cups mix. So we have water and we have mix. 3 cups water, 4 cups mix. Angel needs to make a large number of pancakes. She has 23 cups of mix. How much water does she need? Okay, so there's our unknown. My question is, Ignore that phone call in the background. My question is, does it start through 0, 0? Is it proportionate? Is it proportionate? So we want to know, is it true that she needs 0 ounces of water if she's not using any mix? Well, it sounds to me if you have 0 ounces of water and you wouldn't need any mix, means you're really not going to make any pancakes because you would be following the correct direction. So it is proportionate. If you're not using any mix, you don't need any water, and if you don't have any water, if you're not using any water, you don't need any mix. Yes, it's proportionate. So when it's proportionate, we can take cross products. Back to 7th grade. We want it proportionate because we can solve quickly using 7th grade work. So we get 4 times x. Feel free to use your calculator there. Multiply by 23 times 3. 23 times 3 gives me, what does it give you? 69. So 4 times x equals 69. Solving, divide by 4, copy, paste. So we get x equals, so we have 69 divided by 4, and we get 17.25. So we're talking about 17.25 ounces of water, or cups of water. So we would say the answer then would be, if I have 17.25 cups of water, I would need 23 cups mix. And there's my answer. We were able to do cross products because it does start at the origin 0, 0. All right, moving on to our next problem here. For our next problem, Elizabeth and Dominic run Grandma's Marathon every year. This year, Elizabeth will be running her 6th consecutive Grandma's Marathon, and Dominic will be running his 10th. How many marathons will Dominic have run when Elizabeth runs her 12th consecutive marathon? So let's go ahead and start pulling things in together. Elizabeth and Dominic run Grandma's Marathon every year. Important information. This year will be Elizabeth's 6th consecutive. That means in a row. No breaks. So we have Elizabeth and we have Dominic. Elizabeth is on marathon number 6. Dominic is running his 10th this year. How many marathons will Dominic have run? There's our unknown. When Elizabeth runs her 12th. So the question is this 0, 0? Does this go through the origin? Is it proportionate? Is it true that they started running their marathons at the same time? That's really what we're asking. When Elizabeth started running marathons, did Dominic also start that same year? The answer is no. It even says it up above. So no, they did not start running at the same time. Then we have to add or subtract in the table. It shows here that Dominic is always 4 marathons above Elizabeth. So when Dominic runs his 10th, Elizabeth is at her 6th. So therefore, when Elizabeth is at her 12th, Dominic's going to be running his 16th marathon. So we have this coordinate of 12, 16. When Elizabeth runs her 12th, Dominic will be running his 16th. That's our idea of you can't take cross products, so you have to add or subtract in the table. All right, so let's talk about our summaries for today. If it begins at 0, 0, then you can take cross products. If not 0, 0, then you have to add or subtract in the table. Go ahead and get those notes down, guys. That's kind of the key for today. If not, you add or subtract in the table. Okay, so your homework for tonight, guys, is to finish page 15 and page 16. Make sure on every one of those questions you ask if it's proportionate or not. Does it start at 0, 0, yes or no? Have a fabulous night, 7th or 8th grade. Sorry.